All right, here's the thing. I don't know if my audio is actually nice. The fan is on. It's right there. It's turned on. I should. Okay, yeah. I increased the font size. I think I increased the font size. Should be bigger in a bit. All right, man. Thanks. All right. Let's see. Huh. Yeah, I should have like thought all this through before I just came on the stream and say yapping and speaking nonsense. Well, anyways, I think in the last stream I just did some 1 minute. All right, so as I was saying, I think in the last stream I just did some UIs and stuff, and it was quite simple. But I made some changes, after the stream. Like I actually tried to make the UI work. So if we let me restart Z. All right, cool. Let me take a look. All right, so if we run this, we can now see that it actually works. Like, it actually works. There's a 2 minutes focus time, and there is a 1 minute break. So there's a lot of problems here, but we'll discuss that in a bit. First of all, I'd like to go over is, hey Claire, how you doing? Thanks for joining. Thanks for joining the stream. All right, so like I was saying, we have this 2 minutes timer, focus time, and then the font of this guy, I can't increase the font to you mean the font of the UI, right? I can't increase it yet. I don't like, I just made the whole thing small. But this is like, it's like fixed size. Even if I increase the font size was fixed. So I can't really increase it. Sad, but I mean, sometimes you can work on. So yeah, like I was saying, the so there's a 2 minutes focus time, and then there's a break. Oh, okay, cool. All right, let me take it up a little bit. Let me go right here. I prefer to use the settings of JSON. I mean, the UI was an improvement, but you're eating. Can you say well now? Try make it 28. Are you using glasses? Oh my god. But I think this should be big enough. This should be big enough. Okay, so what I'm going to do. Oh, my old the thing is I want to like save the stream defaults. Like if you look at it, I have 2 settings here. So like I want to like make sure it's fixed so that when I'm streaming again, I can always just because when I'm working, I leave it here. This is like my normal work size. So I don't want to lose that setting. So I just comment it down and I come here. So when I'm streaming again, I want to like make it this big. All right, cool. So so what I'm going to do now is start over by explaining what I did the last time and what I. Oh, by the way, okay, it's similar now. So I will explain what I did the last time and what I did after the stream, and the changes, because there's some stuff I learned after the last stream that I want to like share, and then I'll go over I'll go over what we'll do next. So so yeah, let's begin. Yeah, so in the last stream I started off by setting up the gpui, should I call it the templates on application. Basically I just took from the I just took the code in gpui.rs. So I just took the code right here and I started off with this. So we set up the application and the assets, run the whole thing, and I think I explained why I had to do this and a couple of other things. But now the new thing I added was this guy. Let's see. Oh, by the way, this is how it looks when it's on break. UIs in GPI can be very strange. I'm still trying to like take a deeper look. I still don't know how to do animations or manipulate SVGs, but maybe in time we'll get there. Let's see. I can't remember where I put the original logic. Oh, it's right here. Okay, so this is the function that gets called when we start the timer. If we take a look at the button here, which is the main button or action button. Where is it? Some button roll. Shout. Okay, yeah, that's the second button. So this here is the action button. And the text, we're getting it from here. So if it's running, we change the text, blah 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 blah. So what I did was I added this guy, the click listener. So basically it's a function that gets called when we click the button. So we just listen for the mouse up event, and we assign the listener to this guy. Now, because of Rust's strict ownership, here's one thing I learned after the stream. This application class, this timer app right here, the struct. So the moment we pass it on to this guy here, it becomes the owner of gpui becomes the owner. Like gpui becomes like the owner of that struct or instance of the struct. So whenever we want to make some manipulations, we'd have to use like entities. We'd have to use entities. I think entities as GPU's way of handling the whole memory management thing with Rust. I think there's a book that actually explains this well. UI book. It's not an official book though, but should be here. Flashbang. Let's see. I don't know if I'll need my Wi-Fi on for my VPN on for this one. Oh, cool. Yeah, so GPU uses this for state management. Basically, you have all the structs that eventually becomes children of the GPUI application. I say children, meaning like GPUI actually owns it. So we pass it on to GPUI, and GPUI is responsible for, manipulating the structs and their values. So basically, this is GPUI's answer to state management. At first, I found it tricky because, why do we actually need that? We could just manipulate the values and play with things, anyhow we see fit. But let's get to it. So when we click, where is that? Yeah, when we click this action button right here, we have to pass a function. Typically, we could just pass a function like so. Let me take this out. It's going to be a closure. If you take a look at the signature, we'll see it's a function that takes in a reference to the events, mutable reference to the window and the app, and then returns. Okay, it doesn't really return anything. So it could just be like the closure, the events, the window and the app. So we could just perform an event, or perform just do something right here, stuff. But this would work. Oh, gpui is the framework. This guy, GPU right here. So basically, I think at around 2022 or 2020, I think that's when I started this project. But this Z editor that I'm using, this one I'm using to write this code, they use GPUI to make it like this GPUI. Z used GPUI to write it. So the whole thing was written in Rust. No, I'm not using any crates for GPUI. If we take a look at my cargo.toml, by the way, you can check out the repository in the description. I think right there. I can just check it out and see what's up. So gpui is the only tool I'm using here for the desktop application. Handles the whole thing, the window, the UI, the events, and just kind of like, just neat. I'm using it anyhow here though for error, try to say error handling. Oh my god, Rust. But yeah, I'm not using any third-party crates. However, there is this one by Jason. Let's see. So there's this project by Jason. It's for GPI components. So if you don't want to write the whole thing from scratch, you can decide to pull up this guy. I think Longbridge is a trading firm or something like that, and it's also written with Rust GPI. So yeah, this is right here. The guy already added lots of components, so you don't really have to create anything yourself from scratch. And he wrote a good doc, so yeah, props to him. Again, I think anytime I'm making a GPI stream, I always give him a kudos or something, because he really did a good job. He really did a good job. I mean, I've taken a look at the code and it's crazy. So yeah, back to where I was. So we could just pass in this guy, and then when we run the code, or when we run the application again, so you can see it just prints stuff. When it comes to manipulation of especially internals, let's say things like you have your timer app here, and you want to make changes to this. You want to actually manipulate the internal structure of the application. Let's say we do this. This here is the okay. If we did self dots is running, it goes through. Thanks so much, Claire. So you can see there's already an issue here with the borrow checker. And the issue is in this function here, we are already this function takes ownership of self. If you look at the signature here, you see on mouse move up, and then the next tab is right here, self. So it's not taking a reference. It's not it's not taking a reference. It's taking the object directly. It needs ownership of the object, and it has to return it right here back to the outer scope. So when this guy has ownership of the object, and this guy here intends to take ownership of the object again, it just ends up being an issue. So what we need here is a reference to self, and GPI represents the structs as a weak reference. So here is the mouse events, here's the window, and here's the app. But what we need here is the timer app. Mind you, we just want to set running to true, and we can't do this here because borrow checker. So this is already an issue. So we need to run this, or is that we need to run start timer. So this self is the whole thing. So we need to run start timer, but then there is this issue of the borrow checker. So how do we handle that? We are going to pass on this function directly to another function called listener. So listener passes a weak reference here, a weak or immutable reference to self. right here at the beginning, because GPI already has ownership of the whole thing. Now, I'm probably not explaining this well or in the best way that you would, get to, because even I have limited knowledge. But here's what I understand based off of what I did the last time, after last stream. So what I did instead was, where is that? Right here, instead of, getting self once again, when this guy here already has ownership of self. First one was called a listener. So if we look at the doc string, we see it's a convenient method for accessing view states in an event's callback. When we passed in the closure and try to take hold of self, we run into the borrow checker issue. But this already kind of makes things easier. So many GPI callback takes the form of this function signature here, but it's often useful to be able to access the view states in this callbacks. What I mean by the view state here is probably you have a struct, and your struct has a text. You want that text. Let's say you want to change the value of the text in the closure here. You might need to want to access that state, but you can't really access self here because of the way this whole thing is designed. So what do we do instead? We use this convenience method here, which is a listener, and then what is going to be the parameter would use this self.start timer, and I'll explain why this works. Let's take let's look again. Self. Okay. Alright. Okay, so I'll explain why this works. Let's take a look at this function here, handle button. Oh, let's start from here. So this listener takes in this function. Now, self here is not it's not this object, it's not the instance of the struct, it's the class, the timer class or the timer app. So it could basically just be timer app handle. This is probably still the same thing. What we're doing here is passing the function to listener. Now we are not passing the self. Whenever we do self.handle action button, self is passed here by the call self.dots. But right here, timer app, and we pass this namespace directly. We're not passing self into this function. We're giving this function to listener, and since gpui owns the timer app at this point, because we passed it here, gpui could just pass in a mutable reference here. To pass an immutable reference to self here, and then it will just work as intended. If we go right here and do action button, we see that we need immutable reference to self, we need the events, because we're passing it to listener, and we need the window, because we can have multiple windows, like 2 windows, and then we need to know who's actually triggering the event and stuff, and we need the context of the application. And then here we can now do our shenanigans in this function. GPI passes this parameter as itself, so we don't have to worry about that. If we run this and we click, we see states running equals false, because this is what we printed here. So that's the one thing I learned after the stream yesterday. So I just wanted to make sure I share that up. I'll share that with you guys and make sure everything is cleared up. So after that, what's next? Our actual logic. Now this part is a little bit tricky because I had to kind of rush it. So there is a big problem. When I run the application, we see this. So it starts from, it's a 2-minute timer, it's a 2 minutes counter. every second, it drops. So in order for us to understand the problem here, let's take a look at the function. I can't remember where I put that. Oh, right here. So basically the function says if it's running and it fresh starts, ignore the fresh starts. I will get that later. But if it's running, return. So that means if the timer is running, we don't run it again. If it's not running, we set the running to true. Hasn't finished, we have to make sure we set that up. Ignore this part for now, I'll get there. So what we do here is that we spawn a task. So basically a task is like an asynchronous operation. It's like a background operation, like something like really quick and short. We're just saying here's this function, I want you to like execute it, but I don't want it to block the execution. I don't want to block the GUI thread, the GUI process. So I just want to like have this task that runs somewhere else. So that's basically what we're doing here. So now let's look at the task, because this is the actual thing that runs the timer. This function just like triggers it, but this is where the whole loop, the timer loop runs. So if we take a look at the timer function, in here we see our loop. So what do? Wait 1 second, and then we process, the whole thing. Basically, we are checking if the time is up, if we need to end if we need to end the timer, if we need to redraw the UI, that's all we're doing right here. After we've waited for 1 second. So after waiting 1 second, we check everything here, we process what to do next, and then this right here, just like after processing everything, we tell, oh, should we stop or should we continue? So if we should stop, if it's not running, if we process everything and we say, oh, we're not running anymore, we want to kind of just break the whole timer, want to stop the timer basically. And that's cool, but here's the issue. Let's look at the timer once again. I don't know if you guys can really tell or notice, but this is not 1 second. Like, it's obviously not 1 second. Like, it looks like it's changing every second. It looks like, oh, it's a tick. Well, it's not 1 second, and that's what the problem is. And I'll explain why. Although our code says wait for 1 second and then process, we actually add an extra overhead. And way we're doing that is here when we are processing it. So this whole thing might take a second, yeah, but then this whole code here also takes at least a little bit of time to process. Like I think I would like to say that it's not visible. It's not like really visible to really notice. But anyway, I can kind of like just feel that this is not 1 second. I can feel it. I know what 1 second feels like, and this is not 1 second. This is like 1 second and some extra milliseconds. Let's say 50 or something. I can just feel it, and that's what the issue is. This guy right here, the whole checks. I mean, the checks might not really take that much time, yeah. But whenever we call cx on this file, we're trying to like tell GPY to, hey, we've changed some values, we've changed some state values, and we want to, redraw. So basically, like we've changed the value and we want to redraw the screen. So I should put it out there that GPY is an immediate. It's kind of like. It's like kind of hybrid. So it's not like we have states and then when we change that states, UI triggers like MS. Oh my god. Okay, so it's not like we have states that we can just play around with, and whenever we change the states, it just retrigger. It's not entirely like reactive. It's just there, it's like immediate. You actually tell like, oh, after this I want to redraw this. But in a way, GPI is hybrid. And that's kind of cool because that way you get to have states, and then you get to have the immediate mode. You could look up what immediate mode GUI means later, but I think I should pull up something real quick. Immediate. There was the okay, so it's an API design pattern in computer graphics where the client calls just there's too light. There's no dark mode here. My eyes. Anyways, so it's an API design pattern where in computer graphics libraries where the client calls directly causes rendering of the graphics object to the display. So that's what happens whenever we call cx.notify. If I comment this out, cx.notify everywhere, let's start. So we've started here. He knows what 1 second feels like. I feel you, bro. So I already clicked the button here, but then we're not actually redrawing the screen. Now the values have changed. Itself that is running is true, but then we're not drawing anything here yet because we don't know because we have not told the graphic guy to draw. Yeah, so let's just see what happens when I leave the button. You can see that there was an update, and the reason that is because the button has a hover effect where I say if the mouse button enters here, I want to change the style. If it leaves, I want to change the style. So that's why we get an update in that time. But we can see an update is happening already in the background, but we are not rendering to the screen. So that's what immediate mode GUI is. So the code here has to tell GPU that, oh, I am ready to draw because I've changed the state of my application. So that's what's happening right there. Unlike things like React Native, you basically just update a function, and then the API has to decide. I said an updated function. Updates a variable or something, or a ref, and then the library or the framework has to decide if it's okay to redraw or re-render the UI. So that's the difference since state modes and immediate mode GUI. But GPI is kind of like a hybrid. I don't really know where I don't know where it stands in between, but it's kind of like a hybrid, and let's just respect that. And we just have to call notify everywhere. So that's kind of like why it takes a little bit more time to actually like show up, or why 1 second here is not actually 1 second. And that's the problem. So now how do we fix that? I don't know yet though. If you look at the description of the video, I said expect chaos. So I don't really know yet, but that's what we're going to figure out. That's what we'll figure out. So anyway, for everybody that's already here, thanks so much for joining. I really appreciate it. I see the the view counters quite impressive today. Hey, hashtag hi, thanks for joining. So yeah, like I was saying, I see the viewer count is actually quite impressive today, and I really appreciate you guys for joining. So yeah, since we've already pointed out the problem, how do we, come up with a solution? I use AI sometimes. Let's say if I'm working on like web applications, I don't entirely feel like AI can help me well here, because GPUI is not. I think Rust in general is not entirely like, should I say, mainstream enough like the web is. I mean, it's mainstream, but to AI, sometimes when I'm generating like AI code, lots of errors that I have to like fix. Even in web, still lots of errors, but at least it's quite better. So I use AI whenever I'm working on web projects, and I was like spin up something really fast, like a quick dashboard or some quick function. And I use AI when I want to understand code. For example, gpui does not really have docs that much. Yeah. So what I do is I take the whole gpui code and I index it and ask questions. How do I do this? How do I do that? How does Z handle this here? So that's kind of like what I use AI for in my workflow. So 1 minute. I think I should grab a bottle of water. All right, I'm back. So yeah, we've identified the problem, and we have to. So now, how do we like fix it? Okay, I think one thing we could do is okay, so if we take a look at the counts that are increasing, let's look at the process part. So how we even counting it? We're looking at remaining seconds, and then we are reducing it by 1. So basically, like we're just like reducing the time by 1 second after every second has passed. I think the first thing to do here, to be honest, is to kind of like increase the accuracy of increase the accuracy or precision. I don't really know what word to use here, of the timer. So I don't want to like be counting down in seconds. I want to be counting down in milliseconds. So instead of 1, I want to increase it by 1,000. So that would mean that here in our session, because we're storing the pomorodo session right here. I want to make this oh, so then that second counts. So this is, let me take this off. Let me put it like that. So this is 1 minute, yeah. 60 seconds times 1, that's 1 minute. So this will be 60. So if I want to say, make it in minutes, like my seconds, I just like, multiply by 1,000. And this by 1,000. One session. Okay, so here when we are like reducing the time, I also reduce it by 1 second, so that'll be like 1000 milliseconds. Now this alone does not fix the problem. Just to make it clear. Let's see, here's this. So this alone does not fix the issue. It kind of just wait, no, oh my god. no, okay. I think here when I'm formatting the time, I'm supposed to like total seconds divided by is that it? I don't think so. No, I don't think so. Supposed to multiply this by 1000. Yeah. Okay, this should work. Oh my god, what have I done? Oh no. Oh man, I got it. Oh, it's total time of milliseconds, so it will be time total seconds. Total ms 1000. Okay, yeah, this would definitely make sense. All right, cool. So we're back. As you can see, it works as usual. Like there's no actual change in a way. There's no real improvements. All I just did here was to improve the accuracy of to improve the precision in which we count. So basically I don't want to count in seconds because we could have some millisecond slip, so let's just count some milliseconds instead. So now how do we actually fix the issue? What I want to do instead here is use time difference to to watch the time. So we will wait for we could wait for 1 second or like less than 1 second, but what we want to do is have like when did we start, and then what time is it now? Let's see. Oh my god, yeah, like it's crazy. Most times it can be very, very readable, but then understanding it is something else, right? You can just look at this code and understand what it kind of does in a way. Like if you knew the scope of all those guys, like if you knew the scope of self, entity and the stuff, like you can easily just say, oh, I understand. But if you don't really know completely like what's going on at the back, you kind of get lost. So you can write readable code, but at the end of the day, it's still something. Still something that you have to like look through and like just figure out for yourself, you know. Okay, so I'll just like explain the logic behind my new my change. So basically what I want to do is right here I want to kind of like just what time is it right now, so I could say time at the beginning. So the time at the beginning will be okay, let's put something. So we need to get a time at the beginning of the loop. We say instance now. So we want to get a time at this point. Yeah. So I think we should wait for a shorter time. Like I want to process this every let's say every let's say 200, or let's say every 200 milliseconds. I want to like run this loop. I want to run this process every 200 millisecond. I can just say from this second, say to 100. So I want to wait 200 milliseconds, and then I want to calculate the I want to like get how much time has passed. Oh no, I think I feel we might need to do something with this guy, but for now, let's just go on. Let's see. Okay, so yeah, at this point here, I want to get how much time has passed since we actually did this. In a way, it's going to be 200 milliseconds, like for the first loop that we run. So if we do it's how much time has passed. I don't know if we could do minus with this guy, time at the beginning. Oh, cool. Still got an instance. But we get a duration. Ah, smart. All right, cool. So now it looks like nothing is, it looks like there's no points on this, right? Because obviously we know that it's 100 milliseconds that's passed in the first instance. But now let's just go on and just see what's up. Oh, okay. If you're just starting out Rust, I'll recommend what was this guy's name? Okay, there are two guys I'll recommend to you. One would be Let's Get Rusty. He's really good. I think I watched his videos a couple of times. And the other one would be Chris Bacardi. Now here's the thing. I wouldn't really say like if you're a beginner you should run to Chris Bacardi. I think if you are a beginner and you want to see what you can do, like you want to like just expose your mind to the possibilities of, hey, what can I do with Rust? Or what are the interesting things I could do with Rust? You can check out Chris Bacardi. He makes a couple of videos on Nanoi, Bevy, really interesting stuff. GPU programming, creative programming and stuff like that. And one other place you could look to is this guy. you can check out Free Code Camp. Now, I know these guys do like tons of videos, yeah. But then there's this particular guy. He looks like someone from like the medieval times. But I remember watching his videos. So Campros. I remember watching his video one time. I think this is it. Yeah, I'm sure this is it. Let's see. Ads. Oh, I'm not signed in. Skip. Oh yeah, he's the one. You can see his face right here. Yeah, he's the one. So you can check out this guy. I think he's the one that did the same one from 3 years ago. He explained Rust very well. Let's take a look at this one too. I think it's the same person. Oh, it's not. Oh, it's not the same person. Okay, so this particular one here, I watched this and it was really cool. It has 1 million views on YouTube, so you can check it out. And then you can check out Let's Get Rusty. So yeah, that's my recommendation. Oh, you're welcome. You're welcome, bro. All right, let's get on. So like I was saying, in the first instance, yeah, it looks like 200 milliseconds, that's all that passed. But what we want to do, like the main thing that actually takes time is this guy here, this process. So what we want to do instead is to like get like what was the last time, you know, that we calculated the time. Like when was the last time we got the last time? Like when was the last time we calculated the time? So we would want to like put this outside, yeah. So the time at the beginning, so it's not entirely with the loop. Now once again, the time passed is still 200 milliseconds at the beginning, yeah. So what we want to do here is, you know, kind of make this mutable. So it's a mutable, you know, variable. And right here, after the time passed, when we are done running all this, you know, code, and then we come back to the beginning of the loop, we kind of like have, you know, this guy waiting again for 200 milliseconds, and then we do the check. So we have to update it at some point, you know, and that will be right here. So immediately we calculate the time that has passed, we should update the last time we calculated the time passed. So that way we can like keep track of all the times that has passed, even if we took some time updating this whole or running this whole thing. So what we do right here is say time at the beginning equals instant. Now I think we still have to do some stuff though. So, all right, cool. That works. So now we oh, the impact of AI in low-level programming. Here's my take. Once again, it's my personal opinion. Now, AI in low-level programming is pretty much like trash at the moment. I know that AI is good and it's kind of like getting really good. But to be honest, if you use AI when you're working on really low-level stuff, you just see how broken it is. And that's not entirely because it's bad. It's because it's not good enough, you know. Yeah, it's like let's say you've not actually spent time, you know, writing Rust code. You can't be like that good. There are tons of, you know, web examples on the internet. You see lots of you know, coding tutorials on JavaScript, React, Vue. You know, they're out there, right? So when you're training these AIs, like there are a lot of like, you know, training samples to pick from. You know, there's a lot of you know, things that they've worked on, a lot of projects, open source project online, explanations online, because you really need to like at least tell the AI that, oh, this is a good code. Even if you have the code, you need to know that it's good. So yeah, it doesn't really have much. I mean, it does, but not as much as you get with the web guys. And so its impact in low-level programming is it's felt. Oh my god, yeah. You're actually paying to generate errors. Because if you really don't know much about what you're working on and you just give it to AI to vibe code for you, you kind of like just spend a lot more of your time and money fixing those errors. And that's why you actually need to be grounded yourself in those things in programming, and in a way that's why AI cannot really take our jobs. To be honest, like someone needs to like check it out. Someone needs to like keep it in check. I mean, it would definitely reduce the number of jobs in the software industry, in the tech industry, but we still have our jobs at the end of the day. You just have to be good enough. So yeah, AI's impact in low-level programming, it's pretty much felt. Like you can really feel it, but it's not there yet. It's getting there, but it's not there yet. Yeah, so like I was saying, we get the time, like we update the time at the beginning right after we pass the time. So now how do we now use this time pass? We need to get this time passed in millisecond. And I think I should explain why we have to do this. Now let's look at this scenario we have. I don't know if I should draw this because I need to like kind of like explain it well. How do I draw? No dark time for this. Oh yeah. Okay, at the first point here, where we have time at the beginning. I think I should make this big. So at the first point here, where we have the time at the beginning, let's just imagine like it's relative, so it's 0. So let's say we start at 0. Let's say we start at 0 time, yeah, and then we start the loop. So this loop is its own self-contained area. Yeah, so this is the loop here. And then next thing we do is we wait, right? We wait for 200 milliseconds. See, wait 200 ms. So we wait for 200 milliseconds, and then what's the next thing we do? We get the new time. So we get the new time, and the new time here is, let's see, it's 200. Yeah, we know that the new time is 200 because we only spend 200 at the middle. 1 minute. So we get the get now. So we know that this is 200. Okay, so we know that this is 200. And then what do we do now? We update this guy. Let's say, so right here, after getting the time passed, we know that it's 200, yeah? So we update the time at the beginning, which is 200. So we now set this time at the beginning to 200. Now we process So after setting this time here, we are running an extra process before we go back to the beginning of the loop. So let's see, our definitely I will not. I will not. Rest assured, I'll be back. So yeah, as I was saying, after getting the current time, we process, the whole thing. Now this is where we waste time here. This here is where we waste time. So let's just imagine the entire process takes 10 milliseconds. Yeah, let's just imagine it takes 10 milliseconds. Let's see. So let's say this takes 10 milliseconds before we go back to the beginning of the loop. And so this takes 0, this takes 200, this takes this 9610. So we already know that, the last time we checked it was 200, right? So we've set this guy to 200. Now this whole thing is the first instance of the loop. Like this, at the first instance, everything is smooth, everything is normal. But where the anomaly comes in place is right here, this process, because we don't really know how long it takes. It can vary. It can take 10 milliseconds at the first iteration. At the next iteration, at the next loop, it will take 200. It might take 10, 20. We don't know how long it will take, and that's why we want to do this whole complex process, because we want to account for every error that might probably show up. So since at this point we've updated this to 200, so if we set this plus 200, so now we are now 200 milliseconds in. Then here we waste 10 extra milliseconds, right? When we go back to the beginning to wait for 200 milliseconds, and then we get here, so now this time will take 200 milliseconds, so that means 210 has passed. So when we now get now, which would now be 410, if we do a subtraction from this one, we get 210. Like 410 minus 200 will be 210. So that means at this point we now know that, okay, this whole thing took extra 10. This time between here and now, and this process took 210 milliseconds. So we can now accurately get how long has passed, and then we can add it to, or we can take it out from our remaining time. So that's the whole logic here, I guess. And I hope it works. I mean, it looks like it would. So right here, we want to convert this duration to milliseconds so that we can, as milliseconds. Oh my, I'm thinking I should even raise it to U128 because I don't know how big milliseconds can get. But anyways, for now, let's just use U64. If there's any rounding error or any issue, we can increase it. But I think we should use U128. But here we have this as U128, and we want to take it as from remaining seconds. We could say time passed. That's U64. So I'm taking it out as U64 for now, but this here is the whole logic. This is what we're doing. Back then we just did wait 1 second, come right here, then come right here, take out 1 second, even if this guy took more than even if this guy took extra time to process. But now I think we actually handle it well. And we can run this and see if it works. It should work as normal, but in this time 1 second should feel like 1 second. Exactly. Can't you feel it? It works. Like I can feel 1 second. Like I can feel the 1 second go. Like this is how time. This is 1 second. This is actual 1 second. Like I knew it. I knew it. The whole process was taking extra time. Like redrawing the UI, like kind of like added like an overhead. So taking out 1 second at every bip, at every loop was kind of like inefficient because we kind of like just lost track. We kind of like just lost some extra time, or we kind of like added some extra time during the whole process. So this really works. Like I can feel 1 second, like I can literally feel a second, and that's so crazy. So yeah, I think this is going to be the this is going to be the whole premise of today's stream. I was thinking I'll be able to touch on some other things like fixing this button, variable time. Like at this moment we just have 2 minutes. Yeah, so it's in an async. Let me pull it up. That should be somewhere here. So I had to spawn it. I had to like spawn a task so that it does not interfere with the GUI, and so it doesn't interfere with the GUI thread or process. Like I explained sometime in the beginning of the video, gpui is like a hybrid mode UI. There's the states mode, and then there's the intermediate mode. So you can look it up to see what intermediate mode means, but gpui is kind of like in the middle. So oh, there was an error. I think it's because of I think it's because as time went past, like as time went by, okay, I think I know what happened. I think I know what happened. Let's see. Ignore. I think I know what happened. It's not this. I mean, it could be, which we're going to take care of, and I think we should handle that first. Let's see. I want this to be U128. I'll explain why that's broke. Let's just this. Okay, now what happened was right here. I think I get what happened. It was attempt to subtract with overflow. So now if you can see our app right here, we pointed out that remaining second is an unsigned 128 bits integer. What that means is we can only take in values from 0 to I don't know how many 128s can take. Okay, let me do a search on that one. So we can take like 0 to 0 upward, like positive integers. Let's say what size is you want to create? Let's see. Okay, it's 16 bytes. It takes okay from 0 to 2 raised by 120 minus 1. Okay, that's what the whole 120 is. Okay, that's cool. At least now I know. So can take from 0 to 2 raised by 128 minus 1. All right, that's nice. So what happens is that here, when we do a minus time pass, sometimes the time passed might be more than the remaining second. So when we like try to like, do a subtraction, we should make sure that we're not like doing, if remaining second is like 5 and then time passes 10, and we do 5 minus 10, something like that, we kind of like get an overflow there, because remaining seconds cannot be less than 0, right? So let's fix that here. So we can say seconds entity that's remaining seconds minus time pass. So I want this to be an I it's I think this value is a little bit too much. I don't know. Well, anyways, oh, my bad. So I want to like get the remaining second, and if it's less than 0, I want to, oh, there's a better way to handle this. No, I don't need to like, I think there's a better way to handle this. I think I just say if time passed is greater than entity the remaining seconds, that means if remaining seconds is 5, we have 5 seconds remaining, and they want to take out 10 seconds. We know we can't do that, so let's just set it to 0. So we could say entity the remaining seconds. I think I was thinking writing this like Python. I could say entity the remaining seconds equals 0. So we know that that's like a big guy, so we can just take it out. Else we could do our normal yeah, so I think this should fix the error. Like, it's just crazy how like 1 second now, it's crazy how I can feel 1 second, and I think it's as a result of playing too many games, play COD almost every day, and then you can kind of like just feel, you can feel where there's a lag. You can feel the 15 milliseconds lag. I don't know, I know there are guys in the stream that can feel me. Like, you can feel the 15 milliseconds lag, and yeah, that's why, like, I just like, that's a problem. You just have to fix it. So yeah, I mean, I'll be rounding up in a bit, and maybe in the next video, maybe like after the stream, I can like do some extra work to fix all this up, like to increase the time. The stop works, by the way. Wait, it doesn't? Oh my god. I didn't attach any function to the stop button. Okay, I'll do that later. Well, thanks so much, guys. With you guys, I was able to fix the whole timing issue, and then it's kind of cool that we made it work. So thanks so much for joining. In the next stream, I think I'll probably be done with this app. I've not really touched it since the last stream because of work. So I think in the next video, I'll probably like be done with the whole thing and just move on to explaining what I did, and maybe sharing resources that I used to it's kind of like make this work. So thanks so much, guys, for joining. I will see you in the next one. So next show is probably gonna be like next week, Friday or Saturday. Like I have to like work, So depending on how work is, I might stream on Wednesday, but mostly Friday or Saturday. So thanks so much for joining. I'll see you in the next one. Bye. Peace. Peace. All right, let's go. Let's go. Okay, I don't know if I should like stay right here to make sure this actually works. I mean, we didn't verify that this works. It needs to finish running. So let's just see if it runs without issues. Thanks so much, Rajat. Thanks for joining, and I hope your Rust, journey is actually like really smooth. And I hope you're subscribed. Because I kind of like just throwing Rust streams from here to there, and not just not only Rust, not only GPUI streams. Like I could do. I was supposed to do a game programming today. Not entirely game. I was trying to like go into like physics to explain some things. I'll try to go into physics to explain some physics simulations, but I need to round this up first. So it's minutes for this to get done because we are 2 sessions in, and then kind of like need some stuff. So I might not be able to verify this on the stream, but if there's any issue, I'll make sure to let you guys know. If it's oh my god. Oh my god, nigga said it. Yeah. Oh my god. Okay, you know what, Raja? I think he's actually kind of right. Don't entirely expect your Rust journey to be smooth because it most likely will not be. But just kind of like put it in mind that you're actually trying to learn something that would eventually pay off. Financially, to be honest, I don't know. I don't know, but the possibilities with Rust are kind of like cool. It's like C, but then it's like high level C, to be honest. Rust kind of feels like low level programming, but with high level aesthetics, and that's why I picked it up. I mean, I'm not on the boat to compare with C and compare Rust and C, but Rust really has its role. So if it's smooth, then it's not Rust you're learning. That's true, but I'm sure you got this. Okay. All right. Thanks so much, guys. I'll see you in the next one.